I'm just seeing. I wanted to reach out.
But today, we're not going to go over like some crazy stuff. A lot of what we want to review today is stuff we've already gone over. Yeah, he'll come back. It'll be fine. I'm not going to go over too much before he gets back. So, right. So reviewing SQL injection, I think we're pretty clear on that at this point. All right. We use prepared query. If we're not using ORM like Hibernate, we like to use these things called prepared queries to prevent us from accepting bad form data from the client, right? Because they could craft a specialized string that's designed to hijack a SQL query and do its own thing, right? I'm on the latest assignment, or no, the latest the Web Apps with Spring unit, and then there's a review lesson. It should be current right now.
Okay.
And current, by the way, is like things that we're currently looking at. So it should show up on like your dashboard or whatever. Do you see that? Yeah. Okay. Let's see. Am I showing my screen? No, I'm not. So SQL injection. What we're going to how we're preventing SQL injection is, one, we use an ORM, so we're not actually running SQL against the database. Two, we use prepared queries. If we're not using an ORM like Hibernate, we like to use a prepared query to keep ourselves from munging strings together to build SQL queries. There's another thing that can happen with websites called cross-site scripting. So basically, if I'm website B, and I know that wellsfargo.com allows you to make transfers to accounts with form data. Like if there's imagine a post request being handled on wellsfargo.com, right? And a post request accepts like the amount, and then it gets the current account from session, and it takes in another account ID. Right, so if I'm an attacker and I have my own account ID and I have a form on my web page that posts to Wells Fargo, then if that user happens to be logged into Wells Fargo, then that form submission will go through and that data transmission will happen, which will potentially transfer you however much money you specify. Right, so that's called a cross-site request forgery. It's when you can post data to like wellsfargo.com or any other website that's not your own, and cause unintended side effects, right? So you kind of see what's going to go on there. Like imagine you were supposed to write imagine you were a developer for Wells Fargo, right? And you're supposed to write a form that allows you to transfer money from account A to account B. So the form might be like, get the current account from session, right? Because you have to be logged in to see the page. Have them enter in the other account identifier, and then the amount that you want to transfer, right? So if that form exists, now when you write a form on another web page, you can post to any other web page. You can post to so you could post to wellsfargo.com/transfer funds, right? And if all that transfer funds endpoint needs is the other account information and the amount to transfer, and then it uses your current session to get the money from, then an attacker could have a form on their web page that transfers money to their account. So this is called cross-site request forgery. It is a thing. It's a pretty big deal. I think it stands for CSRF. CSRF is a thing, and it's one of the most prolific attacks on the internet.
This might be a stupid question, but Wells Fargo, I'm sure, or Bank of America, whoever, probably has things in place where that cannot happen.
Yes.
Okay.
Yeah. It's a cross-site request forgery, it makes it so that you there are things you can add just to keep that from happening for sure. But CSRF is like there's always new and creative ways to compromise websites. So while they do have security measures in place, no system is 100% guaranteed to not be. It's like nothing is bulletproof really. They can do their best. So SSL. SSL stands for Secure Socket Layer, and it's what HTTPS runs on top of. So basically, SSL you can think of it like your encryption layer. So when you deal with any kind of pertinent information like social security numbers or passwords, or any valuable information, you want to make sure you're running over HTTPS, which uses SSL. Okay.
Is that automatically? SSL encryption is automatically with HTTPS?
Yeah, they're almost all the time bundled together. Yep. And secure password storage. So we've gone over the 3 of those, at least to varying degrees before. We haven't yet talked about storing our passwords securely. So imagine we take our application that we built so far, like the game tracker app, for instance, right? Would you use that app if it were on the internet somewhere?
Yeah, you would. But
Will's like, I'm pretty sure the answer is no.
you would, but you wouldn't know that. Like, you haven't put in any security measures, right?
That's correct. So knowing what you know about the application, would you use that if someone else had written it?
No,
No. Why not?
because it would complicate. They could get your cookie, right?
No. I mean, the cookie thing is like when you sign in anywhere, a cookie is going to be stored on your computer. So that's not cookies by themselves is not the reason why. There's a couple of reasons that are glaring to me. We know how we're storing the passwords in plain text,
Yeah.
right? So like if someone were to get the database, all of a sudden they have a list of usernames and passwords.
Yeah.
Right. So that's a problem. Another thing, so we're not running over HTTPS. So if someone, there are programs out there. So think about how wireless signals are broadcasted to these computers, right? The signal is being routed through us. It always drives me, I remember downloading a video game and my router was behind me and I was thinking all the data that's going into my computer right now is traveling through my body. That's insane to me. But wireless networks, they broadcast the same signal in a giant sphere range, right? So your computer is the thing that filters out all the things that don't belong to it, but those signals are still broadcasted out.
Kind of like how we're getting all the wireless networks here.
Yes.
And it's interfering.
Same concept, yeah. There's no way the router can just only send your signal to your computer. It sends everyone's signals everywhere, right? And your computer's job is to filter out all the things that just belong to you and ignore the rest. But there's things out there called packet sniffers. There's a program called Wireshark, which is a pretty popular program for network debugging, but there is a version of Wireshark which will allow you to analyze other people's network traffic.
So packet sniffers?
Yeah. It's basically, sniffers in general are things that just go snooping around the wireless network you're currently on to take a look at the traffic. So if you're not running over HTTPS, then you have unencrypted traffic running over the network. So if you put in your password in a password input field to our computers, it doesn't matter how we're storing it. If you're on the same network, let's say for instance you're at a Starbucks or you're at a Barnes & Noble or something like that, and you use the wireless internet, and you're on a website that doesn't enforce HTTPS, and there happens to be someone out there who is taking a look at all the traffic. They have your password. They have everything. They have your session information. They have cookies. They have everything. Every single thing you've transmitted over that wireless internet connection, they have. So it's important that if you ever put your password in a website, there's a padlock, like up here in the upper left-hand corner here. Oops, I actually clicked it, so it went back. But you see this padlock up here? It's green. You can like zoom in on it. You can like, dang it. There, you can see the information about this guy. So your connection to this site is private. We won't get into too much detail as to how it secures this information. Basically, there's a thing called a certificate on the back end that ensures that this is the website you think it is, right? So if you don't see this green padlock, do not put your user information into that website. So for those two reasons, you would not want to use the thing we've created. So if you ever write anything for production, it's a requirement that you have those things enabled. So let's talk about secure password storage. So the solution to this problem that we've identified is to hash the passwords before inserting them into the database. So you guys, we've seen hashes before. So every Git commit has a hash, right? It's a random series of letters and numbers. Hashes are similar to a thing called encryption. So like if you take like plain text and you encrypt it, the difference between encryption and hashing is that it's possible to decrypt that message. So if you encrypt a message, you should be able to decrypt it, right? But when you make a hash, there is no algorithm by which you can convert that hash back to its original plain text value, except for by like just brute force. You have to try a whole bunch of things. So hashes are not designed for that purpose. You hash your password and you store that hash variable in your database table. So if you want to log in, what you have to do is take that form data that they posted and hash it. And if that hash equals the hash you stored in the database, then you know they have to have had the right password. That's how you log in. But the nature of hashing being the way it is, where you can't decrypt it, means that any website that tells you what your password is, I don't know if you've ever signed up for a website and then they send you an email, it's like, hey, your username and password is this and that. They should not be able to tell you what your password is. No one should be able to know what your password is ever. Period. End of story. If they do, that's a bad thing, and you should discontinue use of that website immediately.
Wow.
I've seen websites where it doesn't even send you an email, just prints it right out on the next page.
Yeah, it's not. Yeah, discontinue use of that website immediately,
Wow.
and/or complain to the webmaster, whoever. I've done that before. Our preferred parking, the people that host, that's where I park, around the corner. The company, they sent me an email with my username and password. And I walked in their office to talk to them about something else. And I was like, by the way, can I talk to your IT staff real quick? And they were unavailable. Big surprise. But I told them, I was like, man, if I wasn't forced to do this, I would not use your service. I would discontinue use because you guys clearly are not storing your passwords properly. And then they sent that feedback. The IT team got back to me and said that we're planning on a release where we encrypt your passwords soon. So.
You know, that's crazy. I remember when that started to like change. Like when I would change my passwords, like I remember noticing like, well, they're not sending me my password anymore. Like now it's like, you know, change it here. Like they'll send me a link to change it.
So yeah, like if you forget your password, you never, like they never send you what your password was.
Right.
A forget your password link is a way for you to reset your password.
Right.
To something else. And that's the way it should be. If you click on a forget your password link and then they're like, oh yeah, your password's this, then that's
terrible.
That's a problem, right? So that's what we're going to be doing today. We're going to be using a encryption algorithm, well, sorry, like a hash algorithm to hash our plaintext inputs so that we can store our data securely and not have to worry about user like data getting stolen. So, right. When you hash, all right, so here's the thing. there's an algorithm that converts your passwords into hash values, right? If someone had your database, right, the only way for them to, if you have hashed passwords, the only way for them to figure out what those passwords plain text values are would be to try hashing all sorts of different values, like basically everything. They hash just millions of things a second and then until you match what was in the database. That is way, way, way slower if the hashing algorithm you're using is just a tiny bit slower, right? So if you choose a very fast hashing algorithm, then that process they have to crack your password, which is called brute force. Like if you try to just pass in everything, like millions of times, it's called a brute force algorithm. You try everything, basically. You reduce the speed in which they could successfully crack your password by a lot if you choose a slower hashing algorithm. Because that in normal use cases, if it takes like a half a second, that's fine for you because you're only making a user every now and then. You're not doing it millions of times. But the difference between like a tenth of a microsecond and a half a second is huge when you're trying to crack the passwords, right? Because you don't want to do it once. You want to do it millions of times, right? So the difference is, orders of magnitude.
How do you regulate that speed?
Just the complexity of the hashing algorithm. So just the math, like the computational speed of the computer to calculate the hash. So that's the thing, is as computers get faster, they're able to decrypt things much more quickly, which gives hackers lots of power nowadays.
So I have a question on when the computer hashes a password,
yeah,
that's random, right? Like the hash is random?
Is it random? It is designed to be random, yes.
All right, so actually my question is if I were to type in a certain password and then it would get put into the hash, and if I was to type in the same password, let's say it got erased from the system and it came out to another hash, it would be a different hash, right?
Sorry, yes, that's a great point. Yes, for the same password, the hashing algorithms are designed to come out with the same output. But whatever that output is random.
Okay.
Right, so you're not supposed to be able to predict what that output is going to be,
right.
But it's going to be consistent every time you hash. Right?
I was just trying to think about how even if you tried a million things and let's say you tried password and it came out with the same hash as this one, how would you know if they're completely random? But I guess. Yeah.
Right.
Okay.
Yeah. That's a great question, though. Cool. I feel like I had something to say, but I guess it'll come to me if it's important. So another thing you can do to reduce the time in which someone can hack your things is to use Assault.
Funny the way it sounded.
Use
Assault.
Sorry, I didn't mean to sound British there, but I guess I did. So the thing is that when you're a hacker and you have you've hacked many a thing, right? And you have lots of data at your disposal. That data corresponds to people's usernames and their passwords and stuff like that. You have a lot of hash values. So when you successfully decrypt a hash value to a specific password, if the next table has that same password, it should have the same hash value. So it's kind of a shortcut. It's like, oh, we've already done this. It was this password last time, right? See what I'm saying? So if your website A and website B use the same hashing algorithm, then when you hash the same password, it's going to be the same hash.
What would be an example of that?
So if I'm bankofamerica.com and I use the same hashing algorithm as wellsfargo.com, right? Yeah, you could, yeah. Because there's several industry standard hashing algorithms.
Really?
You can tweak the parameters, but yeah, they're pretty much the same. So hashes, there's a special key on each computer. So it's like the machine key. Given the same hashing algorithm, the output would be different because it was computed on a different computer, right? So you can use the same process, but the parameters are totally different, and it makes it just as good, right? So it doesn't change how effective the hash is; it just changes the output of the hash. right? So it's not a big deal that they use the same hashing algorithm.
Okay.
But if they use the same parameters and they have the same hashing algorithm, then the hash from the databases could be the same, hypothetically speaking, right? So if a hacker compromises wellsfargo.com and has all their user data and has all the user hashes, and they say, for argument's sake, they have brute forced their way and determined the passwords for each hash value in the table. If they compromise bankofamerica.com, they get their user data. If they find any overlap in those hashes, then they know automatically that, without even brute forcing it, that that was the password they decrypted into last time, so it's likely to be the same password this time.
Wow.
Yeah. So it takes a huge amount of data, and that data is called a rainbow table, right? So it's a table full of passwords to password hashes.
That's scary how vulnerable that makes Bank of America and Wells Fargo.
Well, yeah, I mean, there is that, but luckily there's a thing you can do to prevent that. So when you store a password, you include something called a salt. Then you introduce a little bit of randomness to the hash itself. So like if I store a password and say my password is 123, if the system generates an ABC 123 and then it combines those two things together, so the password would be ABC 123 right? And if you hash that, then that's guaranteed to be unique. So that's how you like throw a wrench in those plans of the people who are planning to use rainbow tables against your database, because there's no way, though there is a chance, but the chance of them successfully executing a rainbow table against your database is greatly minimized if you use a long salt. So like I used 123 as an example, but it could be hundreds of characters long.
It'd be like double as hard, right?
Sorry?
It'd be like double as hard.
It would mean that they'd have to brute force every row, right? And that's your goal, is to make them have to run the hashing algorithm for every entry, for every possible thing, because that's what would take like thousands of years.
Yeah.
Yeah.
That would be ridiculous.
So if they can't shortcut that hashing algorithm, then the only alternative is to just hash, and then that becomes untenable on the hacker's side. So that's why using a salt is like really important.
When you think about that, like it's amazing that hackers actually succeed at hacking like certain things.
So yeah, hackers are very creative. They think about things in like different ways. Like they manipulate systems in ways that you wouldn't think of, right? Hacking is a very deep subject, but basically it requires a lot of creativity on the hacker side. Because like one of the biggest sources of vulnerability is the fact that randomness when it comes to computers is not actually possible. So the way random numbers work, a computer will build called a pseudo-random number. And just the nature of the way computers work prevents it from creating a number that's actually truly random. So if you are a hacker and you can predict the next random number, then you can successfully compromise the system, because it doesn't matter what they do, you can always predict what the next random number is going to be. In fact, generating a purely random number in computation is like one of the biggest open, like if you can develop like a truly random number generator, it would be revolutionary from a computer security standpoint. But I think it might be impossible. In fact, I think that generating a random number generator is NP hard, which is a topic for another day. Rainbows, but basically it's in the class of problems that, so there's like, problems are at different difficulty classes. So like there's like easy ones, like 1 + 1 is 2, and it goes up to like really hard. And there's one called NP hard, which is like, at a high level, it's basically, it's not easy to solve these, right? And there's a whole class of problems that if you can solve one of them, you basically solve all of them. But we'll get into, we can talk about that another time, right? But basically, it's just, random numbers are hard in computers. So, So there's a common hashing algorithm called SHA-1, SHA-1. That's actually what Git uses when you make a commit. When you see that really long string of numbers and letters, that's a SHA password. So you'll hear me talk about it as a SHA because that's what it is. It's been encrypted. It's been hashed that way. So SHA is designed to be fast. So we're going to run SHA 1,000 times in order to get our actual hash value. So we're just going to hash the hash value, right? And hash that 1,000 different times. So a standardized way of doing that is PBK DF2. So you can, if you're interested in this, then you can read this Wikipedia article, but it's not critical that you understand everything going on here. So we're going to open up our Game Tracker project and change it so that it doesn't suck from a password storing perspective. All right, so open Game Tracker Spring. By the way, Avery, did you do the practice problem this morning?
I did, and I was getting
Oh, okay. Okay. Yeah, I mean, did you want to learn about backbone today?
They looks like they're just gonna talk about it for 45 minutes.
Okay.
They've already
Okay, cool. All right, so Game Tracker Spring. So the first thing we're doing in this lesson is we're organizing our classes into different packages. So we've talked about this before briefly, separating your code into different packages, but we haven't really done it officially in our in-class assignments yet. So this is the beginning of that. So if we're going to separate our classes into logical entities, so we have a controllers package here, we have entities, and we have services. So note that we have our repositories here. We have our entities here. So a game and user are both entities in the Game Tracker project. We have one controller right now called Game Tracker Controller. So as a part of this, we're going to refactor this somewhat.
So I've been doing this, and I've been calling the folder I keep the game repository into repositories, keeping services.
You can keep it as
Repositories, that's good.
Yeah, you can if you want.
Okay.
It's just that if you wanted to have another service get data from somewhere else, that might be where you come in.
So these repositories are categorized as services.
Yes.
Okay.
So yep. It's like a service that gives you data, right? So we'll move our controller into the controller guy.
Oh, and does the Game Tracker Spring application go into a directory, or is it just in?
Right now, it's not categorized in a subpackage.
Okay.
At least not yet. So let's make a new package. We have controllers. We have entities. We have the two entities we have are game and user. And then we have services here. Oops, that's not what I want. So in that, we'll put our game repository and our user repository. Okay, so we have everything neatly tucked away, right? So controllers, entities, and services. Looks like I have a access issue here in my controller list. So let's rebuild. User.games is no longer accessible because it's package protected. So we need to actually, looks like we need to add to user a public get games method. Down there, we also have this user.setName Zach. Gosh.
Well, package protected makes a lot more sense now.
Yeah, it doesn't really make sense if everything's in the same package, right? But package protected, yeah, you can kind of see it now, that if it's outside that package, then it's not valid. Okie dokie, artichoke. So let's move on. So let's talk about password storage. Instead of trying to implement the aforementioned features ourselves, like by just hashing, like making the hashing algorithm ourselves, like we're not going to do that. We're going to use one that exists already. So we're going to download this password.storage Java, passwordstorage.java. And we're going to store it in a utilities package here. So the job of this class is going to be give us a password hashing algorithm that we can drop into our controller. So password storage. Oops. What's up? Sure. Well, I mean, it's not super important that we read this. Like, it's going to get confusing. But essentially, this is a class that has a bunch of methods in it that can hash our passwords for us. All right. So that's good.
That whole thing is the hashing algorithm.
It was the hashing algorithm plus some extra stuff. So let's see. So create hash that uses this PB. It uses the actual PBKDF2 algorithm. Wow.
Sorry.
It's okay. So yeah, it uses the algorithm to actually get your encrypted value. So it like this class wraps the PBKDF2 password or the hash generation thing. Okay. And again, at a higher level, you don't need to understand hashing algorithm itself, and you don't need to understand what even the password storage is doing with the encryption. You just need to understand that hashing is an important concept when it comes to you have to hash your passwords. Have to. Okay? And what we're doing is using a class in a nutshell to generate your plain text password into a hash version of the password. So that's another thing is that when you're talking about encryption, the word plain text will come up a lot. Plain text just means the text that you are going to be encoding. So the plain text in this case would be your password, and the encrypted value is whatever you make as the hash, right? All right, so we're going to update our login post request here. Let's go back here to I'm glad I made that method name that, and I forgot about it. So yeah, we're gonna go here to login. We're gonna import the password storage class. And we actually have a compile time error here because we're trying to get user password hash. So that's interesting. Let's just do get password. Right? So when we log in, we're going to say user equals users defined by first name username. If the user is null, they're going to make a new user. The username is going to be whatever the username is, and the password is going to be password storage.create hash, whatever we passed in as the password. Right? And then you save it. Otherwise, if the user is not null and the wrong password here, you say incorrect password. You throw an exception. Right? It's the same login mechanism, except for now we're comparing, instead of plain text values, we're comparing encrypted values, hash values. All right. So save. That's all. That should be everything we really need to run this. So let's run it. So if we open up pSQL at this point, we go to our tables. We have Zach, Hunter 2, and Benjamin at farts. So if we delete from users, okay. Well, we did delete from users games, delete from users, delete from games, delete from users. All right. Actually, I have a user ID still. That shouldn't be there. Let's drop our database here, just to make sure. Because I thought we established a many-to-many relationship. Did we do that for this? Oh no, we didn't, did we? Yeah, we submitted to one, so that makes sense. So I don't need to drop anything. But we do. We have deleted all of our data so far. So let's run our app. Oh, I stopped it on purpose, so it didn't crash. So since I dropped all of my user data out of my users database, the post construct is going to take control over here. And it's going to say users.count is going to equal 0, so we're going to set their new name. Actually, this is going to be kind of broken because, you know what? Let's put this in the. Let's do this. Let's say password storage dot create hash password. Let's just try this. This should never happen, but I'm going to do it anyway. So I can compile. So I am changing my initializer so that you can pass in a string here. And then my setter, which is the job of the setter, is to hijack this kind of stuff. Oh, I'm running it twice. My bad. Sorry, guys. So I added to our setter the ability to encrypt whatever password we pass into our setter, right? So it's like, instead of saying set password and just putting that password in our field, I'm like, pass in whatever password you want to give us, and then when we set it, we're going to hash it, right? And that's the value of actually adding a setter, right? Because you can do stuff like that.
You're doing it like right off the bat.
So you could do the same thing here, but just the way we've written it so far, we are not doing it. Like in the constructor, you could do the same logic, but the way we just have it in our controller right now is we're hashing it beforehand, so we won't change that for now. So if we look at, we restarted our app before we made that change, so it's still Hunter 2. But if we add someone else, like Benjamin, and then I'll put test password, we log in. Password isn't reachable because your application wasn't started. So you have to start up your application.
I was like, huh, not what I was expecting.
Yeah, a lot of things are not working as expected this morning, but it's okay. We're powering through it. All right, so Benjamin, and then test password, login. No, we logged in. I want to store it. So we're logged in now. So we'll log out and say, Benjamin, wrong password, incorrect password, correct. And then we use test password, log in, and it logs us in. So we're good, right? Functionality of login is set, except for instead of storing plain text passwords, we're now storing this guy.
Whoa. Sorry.
It's okay.
Oh, that's neat. That's really neat.
So yeah, now if you have the data for Game Tracker Spring, then you're kind of out of luck for Benjamin because he's encrypted his stuff. Well, hashed it. Sorry, I keep using encrypted. But remember, the difference is you can decrypt encrypted things.
So the plain text, where would you find the plain text? Would you find the plain text?
No, it's nowhere
Awesome.
except for in your mind, which is where it should be.
Oh, cool. I
Yeah.
like that. Well, obviously.
Yeah. So yeah, unless correct, Mike.
Yeah, it's your, on your sticky note on the
Yeah.
computer.
People can social engineer that stuff away from you, but it should only be in your brain.
That's really cool.
Cool. Good times. So next on the ticket here is talking about java.util.date. So the reason why we want to bring this up is because up until now, dealing with dates, well, sorry, before Java SE 8, dealing with dates and times is a huge pain in the butt. So the original date class was kind of strange. So the year that you have in the original date class started at 1900. So to give the year 2000, you do set year 100 to give it a new, like add 100 to the years. So the month is a zero index integer, so you give the month of January was set month 0, but days were 1 indexed. So inconsistencies there. Also, is an immutable object, which means it can be changed, which we'll talk about in a second. And it has no concept of time zones, which is probably its biggest flaw, because then you can't really effectively store data. Because like when you store a time, it should have some context of like where it is with respect to the time zone.
And this is prior to 8, right?
Yes.
Okay.
Yep. So when working with Java projects, you know, to kind of fill in functionality, people created their own packages, like, and released them on Maven, right? To fill in some of the stuff that sucked about older versions of Java. So some of those are still cool. There's actually a framework called Guava out there that Google has created, which is really awesome for this kind of thing. It gives you one, like, if you're in a project and it uses like Java 6, for instance, instead of Java 8, you can use Guava to ensure that you can still use mostly Java 8 stuff, right? Like, it doesn't give you all the things the Java 8 gives you, but it gives you like a lot of them. Like, you can't use generics, for instance, but yeah, there's a lot of things you can use. I would actually encourage you to look into Guava, because chances are pretty high that you'll see it somewhere in the wild, in a professional environment. So, in Java 8, we actually have a java.time package. So the date class in Java 8 inside Java time is the new and improved class that has a lot of functionality that isn't as bad as it used to be. So for the remainder of our time here, and I'll try to chug through this relatively quickly so we can, get to other stuff today because we're about to hit up on our lunchtime here. We're going to build a kind of an event tracking mini application right now. Okay, we're going to do so with the new and improved time class. All right. So the first thing we got to do is go to our Spring Initializer. Right. We got to get web, DevTools, Mustache, JPA, H2, and Postgres. Start at spring.io. We're going to generate a Maven project. We're going to call it com.theironyard. I'm going to do .charlotte this time because that's how I feel today. And we're going to do calendar, what is it? Calendar Spring. We're going to do web, DevTools, JPA, H2, Postgres. Oh, thank you. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Now we need to download that guy. So I'm going to open up a new window here. Go to code and go to August 16. Drag this guy here. Okay. I'm going to open up IntelliJ. Then go to new project from existing sources. This should be pretty familiar at this point. If I'm doing anything that's confusing, then let me know. All right, so we have a calendar spring file here. It's a Maven project. I hit next. I'm going to import Maven projects in automatically because that's how I like to roll. Hit next. That's right naming, and click go. Up in the same window, disconnect our current process. So to give it some time, looks like it's rendered everything now. Let's build it. All right, everything compiles, we're all set. All right. So let's open up our application.properties. We're going to set our data source URL and specify that we generate our DDL on this application startup. Remember, this is how we're generating our databases when we start our application. Spring will not do that unless we set this to true, right? And this is the JDBC URL that points to Postgres. We're going to our local Postgres environment at the /calendar database. Solid? All right. So we have an entity here called user. What's up? I believe you're going to have to do that, yeah. Okay. So let's go ahead and do that like you said. Create database calendar. Drop database calendar. Database calendar. Good. Satisfied, Mike? God. All right, so we're going to make a sub package in here called entities. Yep. So here, new package entities. All right, and then we're going to make a user class, which is our entity here. New Java class user. We're going to import all these guys. Keep in mind that these annotations here are in the JavaFX or the JavaX persistence package and not well, actually that's part of Hibernate, so forget that. So yeah, I was going to point out that this is part of the Java 8 library, but apparently those are added to Hibernate. But that's like strange because I would expect the namespace to match up with the package name, but I guess they decided to not do that. So yeah, we have a lot of our Hibernate jar gives us these classes that exist in this persistence package name. So basically, you're filling in this package data with what was in Hibernate jar file. So it's a little strange. I would expect it to be something related to Hibernate, but it's not. Okay, so the user class is an entity. It has a table that maps to the users table. It has the automatically generated ID column, a non-nullable unique constraint name. We have two constructors. One is parameterless. Remember the Hibernate complained at us when we didn't have a parameterless constructor. And we have another constructor that has a name we pass in. So you can make a new user like so. So since we're storing events, this is a calendar tracking application, we want to tie events to users, right? We're going to make an event entity as well. So we have event. I'm going to import all this stuff as well. One sec, guys, sorry. Hey, honey, what's up? Okay, can you wait like maybe half an hour? Well, I'm wrapping up lecture right now, so I'm gonna need a little bit of time. Okay, I'd love to talk to you more about this, but I'm in the middle of lecture, so I'll talk to you about it when I stop. Should be about maybe 20 minutes, maybe. Okay, I love you, goodbye. All right, so we have entity for events as well as users now. So we're gonna be able to store our events with our users. All right, so now we have a home.html template, so let's make that. Sorry, I'm kind of trucking through this, but a lot of this should be pretty familiar at this point, right? So we have our home HTML file. We take a gander at what home looks like now. We have a login form when there is no user, and if there is a user, we're welcoming that user. We have a logout form, and we have a create event form. Okay. So see we have a now thing here, which we're including our in mustache. So we're gonna have to pass in this now variable to our template. So keep that in mind. We also have a list of events here. So we have a description of the event and the date time of the event. So now that we have our entities, we need to make our repositories that use those entities. They can save, update, and read those entities, right? Does all this look familiar so far? Okay, so we're going to have services. First, we're going to have a user repository that stores users. So we have user repository. Extends CRUD repository. Keep in mind that there is a user class elsewhere, so make sure you import the one that you have in the entities package and not some other random one from the Java library. We have find by first name and user, first of all, so note that. So it's past our standard CRUD functionality, we have find by first name. We also have a find all by order by date time descending. Yeah. We have a event repository here. Another CRUD repository that handles events. Interesting. That's what I thought. So yeah, make sure that I was imported the wrong list there a second ago, accidentally. So make sure that when you import a list, it's a Java util list and not the one that's in the Java C library or package. So finally, lastly, what we want to do is write a controller that performs all of our logic, right? So we have our services, we have our entities that those services are based off of, we have a template, our homepage. We need to write a controller that maps these requests to these functions, right? So we have controllers, calendar spring controller.java. So let's add a controllers package here, new package controllers. Then we have calendar spring controller. Calendar spring controller. I'm going to go here. We're going to take all this code here. Import a crap ton of stuff. There's got to be a way to import classes from pasted content that I have just omitted to learn IntelliJ for years. I just always hit just Alt-Enter over and over and over again until I import everything.
The first one I wanted to import on a couple of them were not the ones that we actually wanted to import.
Which ones?
Well, like the list thing happened for me too.
Yeah.
It wasn't the first one on the list of things to import. So.
Yeah. Okay. So, overview of this Spring controller. See, I like to look at things from a high level before I dive down into the actual functionality of these things. I think it helps helps you make a mental model better of how these things are working together. And actually, Mike, now I'm looking at this, like, you remember how you pointed out the other day, like the difference between in code looking at things from a high level versus and other stuff looking at a high level means detailed. I think this is part of it also. Like, I'm zooming out of this class. You can think of it like that. Like, I'm not concerned about the implementation yet. So I'm looking at it at a higher level, like I'm farther away, right? So looking at it at a high level, we have two repositories here that we're auto-wiring into our controller. Remember, that's using a process called dependency injection, and that's what Spring is giving to us. So we have our events repository and our users repository being dependency injected into our controller. And then we have some request mappings here. We have one get request mapping on the home page, so this delivers the home page. We have a create event post method. We have a login post method, and we have a logout post method. So users are going to be able to get the home page, log in, log out, and create events, right? That's what they're going to be able to do. So if we look first at our home page here, we have our method, which returns a string, which is going to be a template name. This method accepts a model in HTTP session, so we're going to be interacting with session and a model in this method, right? So the current username is whatever we get from session, right? And then we're going to be able to get a list of events from, we're going to get all the events, and we're going to order by date, time, descending. So if the user is not null, then we're going to get the first, the username is not null, rather, sorry. We're going to get the first user at the username, and then we're going to add the user attribute, the user to the user attribute, and we're going to add now to the local datetime.now method. So datetime also has a truncated to thing, so you can get a certain specificity. So there is a way you can specify, like, you know, what you want to limit it to. Yeah. So we had seconds there. So it's going to give us the current date and time truncated to the current second we're on. Okay. So we're going to add those attributes to our model if we have a user. And in every regard, we're going to just have all the events listed out. And then we're going to render the home template, which is going to use that data we passed into the model to populate the page. Right? Perfect. So our next mapping here is a post request to /create event. And we're going to be using session. We're going to post in a description and a date time. So when we post an event, we need to know like what the name of the event, or like the text of the event rather. We need to know when the event's going to take place. So those two things need to be submitted to the server. So again, we get the username from session, and if the username isn't null, which means we have a user in session, we're going to make a new event object, and then that event object is going to be the constructor for events. It takes in a description, a local date time, and then a user that created it. So we have description. We're going to use the date time that we pass in. We're going to use the static parse method on local date time to parse that string into a local date time. And then we're going to get from our users repository the first username the first user that matches that username. And then we're going to save into our events repository that new event object. Does that all make sense? Okay. And then we're going to redirect. So in this post request, we're returning a redirect instead of a template name. So we have login, which should do basically what we expect is logs the user in. And it encompasses by trying to find by the first name from a user repository what we passed in. And if there is none, then we're going to make a new user based off of that and save it in a user repository. And then we're going to always save the name that we passed in as our username. So if the user doesn't exist, then we're making him. Right, so keep in mind we're not using password storage here. This is very insecure. Like, we don't even have a concept of passwords right now. So correspondingly, on logout, we don't really need any data to log out. We just invalidate the session. Like, get the current session, invalidate it, and then redirect. Back to the home page. All right? So let's run it. We have no, like, if you look up here, right here, we have no current run configuration set. So I need to open up my application and click this guy. Remember that this creates the current run configuration automatically for me and just runs it. So this should be something you guys have done several times by now, but I just want to make sure you understand exactly what's happening, is that it's actually updating IntelliJ with the run configuration for that specific class. So we started our web server. It's on port 8080. I'm going to log in. And then I want to say description is, event is take, no, that's like a to-do.
Field day.
Field day. And what's cool about these browsers is that they have this automatic like calendar dropdown. So the reason they can do that is, and we didn't write any of that. All we said here was that this input type is date time local. And so the browser was like, oh, we need to have a date time local field here. So let's say with field day is September 22nd at 12:20 p.m. That's really strange. Can I like, so you can't actually select a time there. You have to like add to the time here. So this would be like 1:30 a.m. I'm gonna click add the event. We have field day. When we refresh, we have field day 2016 at September 15th at 1:30 in the afternoon. I'm gonna log out and it still shows the events, right? Okay. All good so far. So now, well, let's see if here. I do want to go over this because this is relevant to our what I'm going to make you do for the assignment tonight. We have gone over mock MVC stuff before, but I kind of want to make sure you guys run your tests on the repository that you're currently writing. So you have the repository that you wrote for the front-end team over the weekend. They were giving you another day to complete. I want you to write tests for it. So this extra time we're spending, you shouldn't have to, you just bug fixing and writing tests. So that's gonna take the place of a new assignment, just writing some tests for the existing assignment. So how to write tests is gonna be here, right? So we'll talk about this briefly. So let's take a look at what we have currently in our test directory. So you see here in main, we have Java and resources, but in test, we just have Java, right? So remember that we could have our own specific resources for our tests, right? So we've done this, I think, a couple times before. We'll do it again. So we have a resources folder here. And remember that this resources folder is just a standard folder in IntelliJ until we mark it as something else. What we're going to say here is that this is not just any folder, this is our test sources root. So it looks like the same as this resources folder, but there's a little test icon there behind it. So these are resources that are going to be used in the context of a test, right? Then we have an application.properties file, which remember is storing all of our runtime properties. So we have one up here as well. This is going to be used for when we run our application. This one's going to be used for when we test our application, right? So the things we want to add here are the same as before, except, oops. We don't want to use Postgres anymore. We want to use H2's in-memory functionality to do that. So basically, these are tests. The data is going to get thrown away immediately after we create it. So we could go here. Let's generate our file, our test file here. We create a test. We're not going to give it any methods yet. So that created a file here in our test folder. Oh, looks like we already have it here. In fact, let's just get rid of what we just created because this is way better. So let's take this and put it here. Right. So these annotations are going to set up this test appropriately to run a web application context. Okay, so without these, then you would not, like Spring wouldn't know to boot up when it runs this test unless you serve up like this annotation that says we're going to need a web application context to run this test. Okay, so it's basically essentially will boot up Spring to serve your tests, right? It's going to build the whole server basically to run your tests, okay? We're going to auto-wire this web application context, so it's going to generate this for us and pass us this web application context. And remember before that we're going to build these mock requests to our web application. We're going to do so by calling into this this static method called web app context setup. We give it the current web application context. What's up?
Could you populate it there with a user that you could use throughout the tests?
Mm-hmm. Yeah. In fact, if you want to have multiple of these before methods, you could do that as well. Like if you wanted, you could have it all here, initialize here. We have one user set up here. But if you want to make them separate, you could have another one. Like before, just mark it as before, and it'll run before all your tests.
Okay.
Yeah. So web app context setup. Let's just look at the documentation here. It says, build a mock MVC instance using the given fully initialized web application context. So given this web application context, we're going to build a mock MVC object so we can actually use the mock MVC object to query our web application context. See what's going on there? So we need to boot up our server, and then we need to make a thing that's going to pretend to make requests to that server, right? And we're going to use that object to make those requests. Instead of an actual web client, like a browser, we're going to pretend that we're a browser and make pretend requests to a web application. Okay? Alrighty. So the first thing we're going to do is test our login route. So first of all, in order to log in, we need to actually store users here, or have a reference to our user repository. So we add that there. Then we need to add a test method, a test login. Keep in mind, anything annotated with test is going to be a test that's run when we run our tests. Said that like a weirdly amount of times. So we're going to use our mock MVC object to perform a post request with the parameter's name as test user. And after we perform that request, we're asserting that the number of users total in the database is going to be 1. Alternatively, instead of saying assert true, you could do assert equals. So that way you could say the same thing. Let's see here. So this is testing login. Right? Now we want to test the creation of an event. So we need to, first of all, add our event repository to our class, our test class. Now we have our events. And now we want to run a test against add event. So we're going to make sure that we've logged in by calling test login. That's going to make a current user. So we're going to perform another post request. We're going to build it with this mock MVC request builders.post method. We're going to post to /create event. The parameters we're passing in are a description. We're going to call it test event, and parameter name is going to be date time here. and it's local datetime.now.toString. And then we're going to pass in a session attribute called username. So test user. So remember that our create event required a user to be present. So if we don't pass in session attr, then these mock MVC requests are completely distinct from one another. So this call is not going to know any session information that you stored previously. So you could log in. So the purpose of this is just to make sure that at least one user exists in our database. Okay? So after we run this, we're asserting that the number of events that are in our database is going to be just 1. All right. So we're going to run this. Keep in mind that our run configuration up here is now the tests that we're currently running, and not, we have both now. If we wanted to switch back to our app, we just click that. So we run this, it chugs along for a while. And lo and behold, all of our tests pass. And I believe that's everything for today. Yep. Any questions that you can elucidate? How's this feel to you guys?
It's good.
Good? Are you sure? Could you write it?
Yeah.
You think so? Nice. I would encourage everyone to follow today's lesson, and probably each lesson. Like when we do it in-class stuff, it's very guided, and you can look at it and think to yourself, this all makes sense at a high level because we're doing it in class, but when you get home, it's a whole different story. So when you get home, that's where you can solidify the concept we learned in class. So I encourage you to, for anything we do, just to make sure that you solidify your knowledge of what you experienced in class by actually performing, like go ahead and do, like write the calendar app, right?
Yeah, I follow along myself too, so I'll look at it later.
Okay, that's good. All right. So that's all the lecture I have for today. Tonight's homework assignment is going to be, again, wrap up the API. And